Debounce that input signal and we're going to be golden. Debounce. D-E-B-O-U-N-C-E. Debounce. To debounce is a verb, and a debounce is a noun. This is one of those words where you can use it in a couple different ways, but it refers to a similar idea. And to demonstrate what it is, because it's a little complex, I'm going to tell you a story about from 15 years ago, the first time I even had to think about the concept of debouncing or a debounce. I didn't even know the word back then, working as a mechanical and biomedical engineer, but I did run into the concept or the idea of debouncing. And let me explain. We were studying the movement of the human leg, and not in real people, not at that time. It was like of a robot leg made out of metal and sensors and electronics. And you would put this leg in a machine that we built and we would study its motion. We kind of simulated the human leg. Not only that, we actually studied the human leg from medical cadavers, from people who donated their bodies to science because they wanted to advance knowledge. And it sounds kind of gross, but hey, this is how we get a lot of biomedical advancement. And so we would have this cadaver leg or robot leg in our test frame. Imagine like a metal aluminum cage, I guess, frame, where a leg is kind of suspended in there with sensors and motors and things. Well, we were moving this leg up and down, simulating a squat like you do at the gym, right? The ankle is on the floor, the feet's on the floor, and the hip is going up and down. The only way we can control this leg is to measure the position of the joints at every point in time. For example, we had to measure the position of the hip. Imagine a single leg doing a squat. The hip is starting above the ground and it gets lower and lower and lower until that's the lowest you can go, and then you rise back up. There's kind of a limit to how high the hip goes and a limit to how low the hip goes. We had to measure the position of the hip because what would happen if we sent that hip going way down too low? Oof, we would crash right into the ground, destroy our robot leg, or even grosser, destroy a cadaver leg, or it would crash into the floor. And what would happen if we let that hip rise up too far? Oof, that wouldn't be pretty because then you might pull apart your robot leg, or in the case of a medical cadaver, that could be disastrous as well. So we had a position sensor measuring the vertical position of the hip. Okay, that's my point. This sensor would send this or translate this mechanical position to our electronics and to our software, and we could see the position of the hip in a signal, like a rising signal when the hip would go high and a lowering signal when the hip would go low. And during a squat, it's kind of like a sine wave or a cosine wave, it would go up and down. So we had to be really precise about knowing when did that hip, for example, go too high. It had to cross a line, cross a certain height. And imagine as that hip was rising back up again, and it gets right up on that threshold, it's kind of like a racer crossing to the finish line. That's like the hip crossing our threshold. Well, we detect that the hip hits our threshold, all right? But if our hip is moving really slowly and there's vibration around, maybe the motor is like jiggling back and forth or something, or the sensor is jiggling, our signal has a little bit of bounce to it. Our signal has some ripples in it. And if you're right at that threshold when those ripples are happening, it looks like your hip is bouncing up over the threshold and back down the threshold, past the threshold and back. It's like if you're watching a racer run a race and they get to that finish line slowing down and they stop right at that finish line, but they're kind of crossing back and forth past that finish line. It's like, did they finish? Oh no, they went back. Or did they finish again? No, they went back. That's what was happening with the hip in our simulated leg. And we would get these signals saying, oh, stop the machine. Oh, start the machine. Oh, stop the machine. Oh, start the machine. All in a span of a second or less than a second. This bouncing signal became this annoying thing that was telling us to stop and start the machine all the time. And we don't want that. We don't want that. We need to debounce the signal. We need to get rid of that. When our leg was approaching that threshold, we needed to like smooth out the ripples or program something to make that not a problem. That's what debouncing is. It means to develop a system, whether it's in software or electronics or mechanical, that gets rid of the problem of a highly variable or dynamic signal nearing a threshold. And the way we got around it was, well, you could just check, hey, maybe the hip has to be past our threshold for a certain amount of time. Like maybe after it's past the threshold for half a second, then we're good. Then we know you've really passed the threshold. Or maybe it's like, oh, when you're crossing the threshold and you stay there, for 10 data points. Maybe it's not time. Maybe it's the number of data points that you measure. That's when we know we've crossed our threshold. So we programmatically adjusted or debounced our signal. You could mechanically help debounce your signal by reducing that vibration in the hip. Like, why is our motor vibrating? Why is our frame vibrating? That shouldn't happen. If you put in some dampers and some rubber or some compressible material, maybe that'll absorb some of that vibration and reduce our bouncing of our signal. I ran into debouncing again today because in web development, you've seen how when you type in stuff in Google, for example, you type in something to search for and it detects what you're typing right away. Well, some sites want a little bit of a delay because you can type really fast, right? That thing that you're typing into the search box is another input signal that has a lot of dynamic quality to it. It's literally changing all the time. One would say maybe it's bouncing. And maybe you don't want to search right away for every little thing because I type badly. And why would you search for typos and stuff? Maybe you want to wait like 1 second and then take whatever you typed as the input search term. So in JavaScript, you would have to program a debouncing function that does that waits a little bit before you really read in that signal, before you read in that search term. Debouncing ends up being so important in software and electronics and a lot of systems because you don't want to make your measurements cause really erratic behavior in your system. That's what was happening with our cadaver legs. We had to fix it. And that's what people run into today in other types of software too. And you got to fix it. I did my best to explain that. It is a cool word that's important. And that is why it's my engineering word of the day, debounce. Thanks for listening to the Engineering Word of the Day with yours truly, Pius, resident engineer and educator. If you want to support the show and other projects that I do, just go to patreon.com/PiosLabs to donate and learn more. All right, I gotta bounce too. Later.